Good afternoon, everyone. This is George Yohrling from HDSA, and I'm joined by my colleague, Dr. Leora Fox.
Hi, everyone.
I'm glad you could join us for the first of our HDSA research webinar series. So each year we try to give a little recap of the exciting progress that's gone on not only at HDSA, but around the globe in terms of HD research and drug discovery efforts related to finding effective treatments for HD. And that is the topic of today's presentation. Just for those who may be joining us for the first time, we use Zoom meetings for these types of webinars, and you can ask a question at any time during the presentation. Just go down to the chat icon and click chat, and you can type your question in the toolbar, hit send, and don't be shy. Only HDSA can see that question, so the rest of the community will not see who's sending it. And we will answer those questions at the end of the presentation. We are recording this, so if you have to tune off or you have loved ones that might find this interesting and want to send it to them after the fact, you can, within a week or so, go to either hdsa.org or go click on the icon, the YouTube icon indicated by the blue arrow here, and find a link to this presentation. I just wanted to give one little shout out to next month's research webinar. We have Dr. Peg Napolis from the University of Iowa. Will be presenting on February 19th from 12 to 1 Eastern Time. And she'll be presenting on a topic related to understanding brain development as a part of Huntington's disease. This is kind of related to the University of Iowa's formerly called Kids HD program, which is now being called the Change HD, an observational study to understand brain development in young folks affected by HD. So make sure you tune in for that webinar on February 19th. With that, I'm going to turn it over to Leora.
Thank you, George. This is Leora Fox. Thanks again for joining us today. And I want to start off by saying that this webinar is the 2019 HD Research Year in Review, but this presentation is going to be more than just a recap of our research activities and news about clinical trials. It's really how we're taking what happened in 2019 and really the whole decade and using that to think about our goals for HD research going forward. And a lot of really exciting things happened this year. This is the beginning of the first phase 3 trial of a Huntingtin-lowering drug, the first gene therapy trial for HD, a whole bunch of new companies that are focusing on HD. And all these milestones have really opened up the research horizon in a way where we can really anticipate that new therapies are on the way. So with this truly unprecedented hope and with the backing of this community, this incredible community, HDSA has really had the opportunity this year to think hard about how our actions right now can help shape what's coming next in HD research. And so George and I are going to talk about how HDSA is looking at that research horizon and shaping our goals based on the expectation of success. So we're going to talk today about 5 main goals in terms of how we visualize this new horizon. And the first goal is to grow the research field. So there are more companies studying HD, there are more ideas in HD research, and that really means that we need to ensure that there is a pipeline of young scientists and some really bright minds that will continue to bring their expertise into the field and stay there and really focus on human-centric work that matters to families. Second, potential therapies, especially genetic therapies, mean that more and more folks are going to be seeking access to care and to testing. So the second goal is to help expand HD expertise so that there are more medical professionals that understand HD and current HD research, and that more people in HD families have access to expert care and to research opportunities. And we especially want to incorporate family perspectives so that clinical trials are really designed with the input of the greatest experts, the HD families. So Our third goal is to continue providing accurate and timely information about HD research and clinical trial opportunities so that the research moves quickly and that, so that people are knowledgeable about what's coming next. And we're going to summarize the research landscape today as well. And fourth, the aim of HD clinical research is not just to treat HD symptoms, but ultimately to prevent them from ever happening. And it's extremely hard to test whether a drug works when there aren't any symptoms yet to measure. So this is where it's really important to us to help increase the community's involvement in observational research trials. These are trials that don't involve a drug. So we can learn as much as possible about pre-symptomatic HD. And finally, we want to invest in new approaches and new ideas that could lead to tomorrow's therapies. So not putting all our eggs in one basket with the current approaches and clinical trials, but helping to encourage new ideas as well. So first, I'm going to talk about growing the field and how we're investing in young scientists and focusing on human-centric work. The Donald King Summer Research Fellowship specifically supports college and early medical students who are interested in HD and who want to do a summer project in an HD laboratory. It was named in honor of a former HDSA board member, Donald King, who is a wonderful advocate. And since 2013, we have supported more than 20 students. And many of them we know have gone on to continue studying science and medicine and even to continue working in HD. So we really think that investing in these young people is a wonderful way to foster long-term interest in HD research and of course to fund good scientific ideas as well. And these are our 2019 fellows who will be presenting their work at this year's HDSA convention in New Orleans. And they did some really excellent work. So Zach Cook at Brown tested effectiveness of drugs in fruit flies. Chloe LaRochelle at the University of Central Florida investigated aggression in HD mice. Alexandra Putka at Duke University studied a protein called PPAR delta and how it contributes to HD. Colleen Stroline at the University of Pittsburgh actually published some of her results, and she investigated how changes in the Huntingtin protein affect the location of mitochondria, which are the cell's energy powerhouses. So these are some of our wonderful Don King students who will be presenting at convention. HDSA's core research initiative is the HD Human Biology Project, and this really focuses on work in humans and human tissues. And we believe this is really the best way to study a human disease. So HDSA's Scientific Advisory Board this year selected 5 fellows. And they're also studying a very diverse set of topics. Dr. Danielle Larson at Northwestern is looking into online telemedicine visits so that a family might be able to have a neurology visit from the comfort of their home. Osama Al-Dalama at Columbia is exploring how cells in the brain that support neurons, called astrocytes, could be protective in HD. Viligilo Makaite in Glasgow is looking at methods to improve how we detect CAG repeat differences in different samples from families and patients. Ricardo Moro-Pinto at MGH Harvard Medical School is developing ways to shrink CAG repeats, and Saul Martinez-Horta is looking into why thinking difficulties occur very differently in different kinds of patients. So the next research initiative that I want to talk about is the Berman-Topper Family HD Career Development Fellowship, which is made possible by the very generous support of the Berman and Topper families. And this initiative focuses on scientists who really want to devote their lives and their careers to studying HD. And this year's recipients were Dr. Nick Caron at the University of British Columbia, who is working with his mentor, Dr. Michael Hayden, on exploring new ways to get genetic drugs, ASOs, which we'll also talk about, how we get them into the brain. So right now, ASO trials involve spinal injections, and Dr. Caron is exploring strategies that would make it easier for these to be shuttled perhaps through the blood. Dr. Lauren Byrne at the University College London is mentored by Dr. Ed Wild, and She recently defended her PhD successfully, and she is working on a project to detect biomarkers to advance disease-modifying trials. So different ways to measure what's going on in the body and brain before HD symptoms happen, and how we can measure that better during trials. So these are HDSA's 3 main research grant initiatives in 2019, the Don King Fellows, the Human Biology Project, and the Berman-Topper Fellowships. And I also want to look back over the progress we've made in research during this whole decade as an organization and in the field as a whole, and all the hopeful things that are happening this year. So in 2009, we were seeing the tail end of a project called the Coalition for a Cure. It was closing. There weren't any open requests for proposals at HDSA. And in the field, there were just a couple of drug trials happening, and none of these trials panned out in the intervening years. But in 2019, over the course of this decade, we've invested in 23 Don King Fellows, 6 Berman-Topper Fellows, more than 30 Human Biology Fellows. We have new staff and a growing scientific advisory board that are dedicated to research, as well as lots of community research communications. In the wider HD research field, there are 20,000 people involved in the Enroll HD study and counting. There are Huntingtin-lowering drugs in development. There are more than 20 different companies studying HD. So the landscape has really changed in absolutely amazing ways. And these are actually just some of those companies. Oh, I'm getting some messages here that people are only seeing the title slide. Is that the case?
Yes.
Oh dear.
Let us try to fix that. It says enable editing.
Sorry about that, everyone. We were running through our slides and no one was seeing them. Give us just a moment to work on this.
If you enable editing.
Mm-hmm.
Try again. Now go back to.
Let's see.
Yeah, now go to presentation mode. Yeah.
Let's see if this is going better now.
We're good.
We're good. Okay, I think we may, let's cycle back a little bit. I don't know if we can go backwards here. All right. What you've missed in terms of the visual landscape was some of the points that we were making, these 5 points. And then photos of our wonderful fellows across our 3 research programs, and a list of the ways that HDSA has changed and how the field has changed from 2009 to 2019. And now here we are, where there are many companies taking shots on the Huntingtin-lowering goal. So apologies for that blip that we had. Hope you're all still with us. So thanks for your patience. So these are some of the companies that are focusing on Huntingtin-lowering. There are lots of other topics in the field as well, but these companies are really exploring all different ways to combat the genetic source of HD. And this is only for that one topic. We're constantly hearing from and connecting with new companies that are exploring different ways to approach HD. I also want to point out that drug approvals by the FDA in the US are on an upward trend over the past decade, and 44% of the approvals this year were for rare diseases like Huntington's disease. In the past 8 years, more than twice as many drugs for rare diseases were approved than in the previous 8 years. So there's more interest from industry. There are really extraordinary people coming together in rare disease communities to advocate for research and for care. And that is true in our HDSA family as well. So we hope to continue to see this field growing and to help bump up these numbers even more in the near future. And now I'm going to pass it on to George.
Thank you. So we've heard, Leora gave a great overview of some of the research we're funding and ways that we can increase or expand the research field, but it's critically important that we also expand access to HD expertise, clinical expertise, and also include that family perspective in these clinical trials that, you just saw a list of 20 some odd companies that are just working in the Huntingtin-lowering space. We need to make sure that those trials are not about the HD community, but are, designed for the HD community with them in mind. So I wanted to give kind of sticking with the theme of taking a look back as you switch into a new decade. It's always kind of nice for us to think about where we were 10 years ago. And within our Centers of Excellence program, our COEs, we had 20 Centers of Excellence across 17 states, and you can see those 17 states in blue on the left there. But where we stood today, going into 2020, is we now have more than doubled the number of COEs. We have 53 COEs across 31 states, all shown in blue. Last year alone, we added 4 new COEs, one in South Dakota, one in California, one in Illinois, and in New York. And in just a couple of weeks, we'll be announcing the 2020 COEs, where I'm really excited to say that we have a budget of over $1.5 million, which is more than double what we had allocated just 5 years ago. So HDSA is super committed to this really important program that we think is making a huge impact, hopefully on the lives of families across the country. As we prepare for this era of disease-modifying therapies, folks are going to need access to a lot of not only expert HD clinicians.
I think it's still not advancing.
It's not advancing? It's still not advancing?
It's not advancing.
Oh, no. Sorry about that. Bear with us. Not sure why it's not advancing. You see it that way, right?
Yeah, this is what's on it.
Yeah.
All right, so we'll just do it. You can say this.
Maybe if you put in presentation mode, it'll.
Sorry about this, everyone. All right, well, you get to see the slides as they come up. So we'll go with this.
Okay.
All right, thank you. It's always something, even though you do it 100 times, the software has a way of sneaking up on you, even in 2020. So our apologies for that. We don't really know why the slides aren't advancing, but hopefully this will fix it. As I was saying, as we embark on this era of what we hope will be disease-modifying therapies, we think that there's going to be an increasing demand for HD expertise in the clinic. This could be, we certainly believe that if there were disease-modifying therapies, more and more people will be wanting to be genetically tested to see if they qualify to get access to a Huntingtin-lowering drug, for example. And there's more and more need as folks enter into, go to a HDSA Center of Excellence, that we expand access to knowledgeable healthcare professionals that understand HD, such as occupational therapists or physical therapists. And these are just some examples of things that HDSA has been doing over the past year or two to kind of make a dent in that effort to increase access to HD-trained healthcare professionals. And this year, or at the end of 2019, we finished recording and preparing a genetic testing or counseling continuing education course in partnership with the National Society of Genetic Counselors, which should go live in the spring of 2020. We're also funding work at Rush University Medical Center to try to see if telegenetic counseling is feasible in the HD community. We've worked with the American Occupational Therapy Association, as well as the American Physical Therapy Association, to launch educational modules to train their therapists around the country. You can see just with our partnership with the AOTA, we were able to reach nearly 4,500 individuals and distributed over 2,600 continuing education credits for occupational therapists. This helps us to increase our our resource base that we can recommend to the community and into HD clinics. And we've also worked with UAB and Medscape Education to develop and provide 3 online continuing education courses for physicians. And working with the right partner, we've seen that this has been incredibly beneficial in our reach. And you can see that in our 3 online continuing education courses for physicians, we have reached over 12,000 different learners. Let's see if I can advance. Making as these therapies go to clinical trials, it's just imperative that, as I mentioned, these trials are for the HD community, and they represent what the community wants and needs from their trials. And to do this, HDSA has continued to work with the European Huntington's Association and the Huntington Society of Canada on a really important coalition called HD COPE, which is the HD Coalition for Patient Engagement. Here you can see a picture of the group. You can see if I can load this up a little bit. Here's a picture of the group meeting for their 2nd annual meeting in New York City, posing with the Roche Genentech team. This is one of the meetings that they have met with drug developers or sponsors. In addition to meeting with Roche, they met with Wave Life Sciences, Novartis, uniQure, and Azavan over the course of 2019 alone. And in 2019, we expanded the representation to this group to include individuals from Africa, Australia, China, and South America. So we truly are a global coalition representing what we believe is the global HD community. We think that this is so important that I'm really excited to say that HDSA has formally invested in a patient engagement professional. Over the course of the past few years, we've seen this paradigm shift where the FDA and the global equivalents like the EMA in Europe, these are the regulatory bodies that decide if drugs are going to be approved or not for a disease. They're increasingly wanting patient feedback on clinical trial outcomes and protocols and treatment paradigms. So as you can imagine, Leora showed you the slides of the dozens of companies just working in the Huntingtin-lowering space. All of those companies are getting feedback from regulators. They need or should be getting patient and caregiver perspectives to their programs. And with the dozens of companies now in the space, it was a critical time. There's a critical need for professional to assist in these efforts. So I'm really excited to say that Sarah Waite-Ardini, shown here, is joined HDSA effective the beginning of 2020, and it will be serving as our Director of Patient Engagement. I'm really excited to have her on board. She joins us from just down the street in Manhattan, where she was previously the Director of Education for the National Hemophilia Foundation. Now I'm going to turn it over to Leora to talk about providing information on HD research and access to opportunities.
Thank you, George. So, thanks again for everyone's patience with this and the screen. Make that a little smaller there. So, yeah, this next section will hopefully be informative about current clinical trials. And I'm also going to start by talking about some of the ways that HDSA communicates about HD research. And this is another one of our goals when looking at the horizon, because research and especially clinical trials really can't happen without the community being very well informed and aware and willing to participate. So these are some of the ways that we put that information out through HDSA. We have a weekly research blog talking about everything that's going on that week in HD research. We organize research webinars like this one. We have our yearly convention research forum, and every educational day involves a research update. We support HD Buzz, which is scientists writing in plain language about HD research, and our annual research report, The Marker, covers everything that happens during the year in HD research. So when we talk about the clinical landscape in HD, we like to start with an HD drug pipeline. And by the pipeline, we really mean the entire process of creating a new drug by studying HD biology in the laboratory and testing that drug in cells and mice. So those are the preclinical stages of research, all the way through clinical development, so trials in people, and finally the regulatory steps where a drug gets approved. And before we dive into some of the clinical trials, and especially Huntingtin-lowering, I just want to briefly define the steps of a clinical trial, which we call phases, just to remind you what these steps are about. So a phase 1 study is a small study that tests the safety and tolerability of a drug in a small number of people. Usually in the HD field, it's around 20 to 50. That's really focused on making sure that that drug is safe before it moves into more people. A phase 2 is a medium-sized study, usually around 50 to 200 people, and that is also testing safety in a larger and longer way, but also the effects of the drug in the body. And it's not until a large phase 3 study with 200 to 1,000 people where the drug is really tested for whether it can help with symptoms. And so this is the pipeline for 2019 going into 2020. This is a very busy slide, and it's not even everything that's going on, but it really, again, this is to emphasize that there are a lot of companies and academic researchers all over the world developing drugs for HD and starting to test them in people. So you can see the approved drugs for HD movements, HD chorea, tetrabenazine, and deutetrabenazine, Austedo. And then there are also a number of medium and large phase 3 and phase 2 trials happening, and some smaller ones in earlier stages as well. So we'll focus on the latest news surrounding the trials happening in the United States, and especially on Huntingtin-lowering. So I'll start with a trial that began recently, which is called KINECT HD, KINECT HD. And this is a study that is testing a drug called valbenazine. It is already currently approved for tardive dyskinesia, which is facial tics and movements associated with taking certain psychiatric drugs. But this study is trying to see whether this drug could also be helpful for HD chorea, the movements associated with HD. So this study, the drug itself is a VMAT2 inhibitor. It is a pill that is taken once a day for 12 weeks during this study. There is a placebo group that does not receive the drug. And the study is measuring the change in the total maximal chorea score. So essentially, over these 12 weeks, does it help with HD chorea? And it's currently recruiting 120 participants. The age range is 18 to 75, people with diagnosed HD chorea, but who can walk without assistance. There are currently 3 open sites for this study in Englewood, Colorado, Houston, Texas, and Wichita, Kansas, but there are going to be 50 or more additional sites coming across the whole US and Canada. And we are continuing to update those sites on hdtrialfinder.org, and we'll talk more about HD Trial Finder in a bit. We also had some news in 2019 about studies that are in progress, but that completed their recruitment this year. So Azavan Pharmaceuticals is doing a study called STARE, and this is a phase 2 study testing a drug that would treat HD-associated aggression and irritability. Vasinex is doing the SIGNAL trial, which is also a phase 2 study that is aimed at inflammation in the brains of people with HD. And SAGE is doing a study, a phase 1 early safety study that has just completed that is aimed at treating cognitive changes in HD. So we know that these studies have fully recruited, and we're hoping to hear more about the results and whether they'll be moving forward. So before we move on to talking about Huntingtin-lowering, well, really the idea behind Huntingtin-lowering is to stop the damaging actions of the HD gene by lowering the amount of mutant Huntingtin protein that is made in brain cells. So there are different strategies for this that are being pursued by different companies, and the three main ones we have here are intrathecal antisense oligonucleotides. So these are, we call them ASO drugs, and these are genetic drugs that attack the Huntingtin RNA, and they are delivered to the brain through a needle into the spinal fluid. There are ongoing studies of ASOs through Roche Genentech and Wave that George will talk in more detail about. Then there are viral gene therapies, where the genetic medicine itself is packaged up into a virus that requires a surgery to deliver it to the brain. And uniQure has just begun an early study of a viral gene therapy like this, and there are several other companies working on these types of studies as well. And then there are small molecule drugs in development, which would be a pill that could lower Huntingtin. And this sounds a bit like science fiction, but we know that there are companies like PTC Therapeutics and Novartis who are working on just that. And I am going to hand it over to George to talk more about the details.
All right, thanks, Leora. I have to say, as we're in this presentation mode, I'm sure there's somebody out there going, holy crap, they have 85 slides. We do not have 85 slides, so bear with us. I even freaked out for a moment. I'm like, oh my God, we're not going to get this done. So anyway, I want to give you a quick update with regards to the much talked about Roche Genentech ASO trial. This is also called the Generation HD1 study. This is a phase 3 study, as Leora mentioned, testing a drug, which is also, you may hear referred to as RG6042, the RG standing for obviously Roche Genentech. This year they announced, the sponsors announced that they've expanded the participation from 660 to 801. These are individuals with diagnosed and manifest HD between the ages of 25 and 65. And so, as you can see, where these participants are across 90 sites in many countries, this is a global study in nature, there are 3 cohorts or groups that are receiving this drug. One is, this is a placebo-controlled trial, so 1/3 of the individuals or participants are getting placebo every 2 months. Another group is getting the drug every 2 months, and then the third group is getting drug with alternating placebo every 2 months. So this, in theory, they're getting, not in theory, in actuality, they would be getting active drug once every 4 months. What we know is that despite the expanded participation, all the sites in the United States have finished recruiting. And while the participation, total duration in this study is like 24, 25 months, it could take 3 or 4 years or more to find out the results, because obviously not all 801 participants started on day 1. They're being, going in waves. So it's going to take some time to get results for this study. While this study is going on, there are other studies that Genentech and Roche are working on. We mentioned the Generation HD study. There's also a natural history study, which is trying to understand how HD progresses. Can we treat very early to help us understand some of the symptoms that are happening before, or biomarkers or things that are going on before overt symptoms occur. There's something called the Gen-Peak study, which is a pharmacokinetic and pharmacodynamic study, hence the PK/PD. This is basically just looking to see, in case of pharmacodynamic, what the drug is doing to the body, and in case of pharmacokinetic, what the body is doing to the drug, and how it's breaking it down. And then finally, there's the Gen-Extend study, which is an open label extension, or OLE, for folks that were in wrapping up the Generation HD study, or the initial phase 1, phase 2 study from Ionis and Roche, where they're looking to find out and tracking individuals, what happens to these individuals that take the drug for a long period of time. So no results, but the study's ongoing, and all of these, to our understanding, are done recruiting. So the Roche approach is an ASO that targets the good and the bad Huntingtin, the unexpanded and the expanded gene. Wave Life Sciences has a similar ASO, but it differs in the fact that it can differentiate between the expanded and the non-expanded, or and shown here, the healthy or the mutant protein in red. Everyone with HD inherits, a mutant or expanded copy from one of their affected parents and an unaffected copy from their unaffected parent. So you typically have one mutant copy of the gene. The Roche drug cannot differentiate between the red and the gray gene, but the Wave ASO uses a little trick that can detect these little genetic code or signals called SNPs, single nucleotide polymorphisms. They've identified two, SNP1 and SNP2, that their ASOs can specifically detect. And when they bind to it, they detect the SNP, they bind to that SNP, and that mutant Huntingtin RNA is then targeted for destruction. One caveat to this approach is that you have to have one of these SNPs for the drug to work, and therefore you have to have one of these SNPs to actually be a participant in one of their trials. The trials are called Precision HD1 and Precision HD2. Main goal of these are phase 1, phase 2 studies. So really the main goal here is safety, tolerability. Are these drugs safe? This is the first time the research community, has ever tried to specifically target mutant Huntingtin in HD patients. So we want to make sure that they do no harm. Both the Precision HD1 and 2 trials are recruiting around 60 early manifest patients per trial. And we know now that US sites have finished recruiting. And just at the end of this year, on December 30th, we had a press release and a community statement released from Wave Life Sciences announcing that the first top-line results for the Precision HD2 study were announced. And this is kind of an overview of what the top-line results stated. So for the Precision HD2 trial, they were reporting data on not 60, but just 39 participants, that 27 of which had received the ASO, or the active drug, and 12 of which received or assigned to the placebo group. And there are basically three outcomes, or three major things related to the top-line results. First and foremost, the Wave ASO was safe and well tolerated in people with HD, and there were no serious adverse events reported. That's a good thing. And that's the primary goal of this study. Secondly, the participants when they pooled all the participants, the 27 people who received the drug, those that did receive the drug had lower levels of mutant Huntingtin at the end of the study. And there were no changes to total Huntingtin, which is kind of what I think we would expect, given that this drug is targeting specifically mutant Huntingtin and not all of Huntingtin or total Huntingtin. The final outcome or decision or next steps from these results was that Wave will be adding a new group of participants to both the Precision HD1 and HD2 studies, where they will receive a higher dose of drug. In the existing protocol for Precision HD1 and 2, I think the top dose was around 16 milligrams, and now they've announced that they'll be adding a 32 milligram dose to both studies. We also mentioned, I think Leora mentioned that it was an exciting time in 2019 because it marked the very first ever the initiation of the very first ever gene therapy trial for Huntington's disease. And gene therapy is, what it involves is introducing some genetic material into a person's cells to treat the root cause of the disease. Where it differs a little bit from the ASOs that need to be delivered on a regular basis via spinal tap or lumbar puncture, the gene therapy approach, we believe, will only require a single one-time treatment via brain surgery. The drug that uniQure has announced they've started for the trial for Huntington's disease is called AMT-130. AMT stands for Amsterdam Molecular Therapeutics. That was the name of uniQure years ago until they were rebranded as uniQure. And AMT-130 is a piece of microRNA. It's a drug similar to an ASO that can stop the Huntingtin protein from being made. And the way they get it into the body is if you have to deliver this somehow. It's packaged into a harmless virus called an AAV, or adeno-associated virus. And this virus does no harm. It's basically a delivery device for a Huntingtin-lowering microRNA. So the microRNA goes into the AAV virus, and the virus is then injected directly into the brain via brain surgery. And once it's in the brain, it will express the drug, in theory, forever, and hopefully lower Huntingtin in the brains of HD patients. So this study is a phase 1/2 dose escalation double-blind imitation surgery study. Let's go over what that means. It's a mouthful. First and foremost, obviously, this is the first time we've done gene therapy in HD families or patients, and we want to make sure the gene therapy drug is safe. So there's a limited number of participants. 26 will, of which 16 will receive drug, and 10 will receive imitation surgery. What I mean by imitation surgery is they'll have small burr holes drilled into their skull, as would just like the 16 receiving drug, but they will not get an injection into their brain. But they won't know that they didn't get that injection. You can see the eligibility for this initial phase 1/2 trial here, similar in nature to previous Huntingtin trials. And happy to say that recruitment has officially begun in the United States, and in Ohio State, Virginia Commonwealth, Houston, and at the University of Washington, with more sites to come. And it's similarly to the other trials, all of this information is in HD Trial Finder as well as in clinicaltrials.gov. So I quickly recapped the Roche, the WAVE, and the uniQure studies. This is just hopefully to kind of bring it all home and together, how they differ. The Roche and the WAVE approach is an ASO that's delivered via lumbar puncture or spinal tap, whereas the uniQure differs in that it is going to require a brain surgery or injection directly into the deeper regions of the brain. The Roche trial, currently, the Generation HD1, is a phase 3 study, whereas the WAVE and uniQure trials are in phase 1, phase 2. I mentioned that the Roche and WAVE are ASOs, but they differ in that the Roche drug is targeting total or all of Huntingtin, whereas the WAVE approach targets just the expanded or mutant Huntingtin gene. And the uniQure is an AAV virus that targets total Huntingtin in a similar fashion to the Roche approach. Roche Generation HD1 trial is completed recruitment, while the WAVE and uniQure trials recruitment is ongoing. And finally, all of those three studies involve, kind of a non-traditional route of administration. This is not an oral pill or an IV infusion that you can take. It requires going to the hospital and getting a lumbar puncture or brain surgery. It would be really wonderful if we could develop Huntingtin-lowering small molecules that are taken via pill or via liquid. And this is just to say these drugs are being developed and worked on by companies like Novartis and PTC Therapeutics and CHGI Foundation, where they're trying to develop orally deliverable drugs that cross the blood-brain barrier, or BBB. While I don't have a lot of details in terms of the mechanism of action or trial design, some of these trials, clinical trials, are expected to begin in 2020. So kind of watch this space.
All right.
Thank
you, George. So we have just heard about the drug trials that are currently happening in the U.S. or that will be happening soon. But I also want to talk about how the HD research field is preparing now for the trials of the future, and in particular, how today's local pilot studies and large worldwide observational trials that don't involve a drug, how those are really important, because they're helping us to learn what we need to know to prepare for trials that could actually prevent or delay symptoms. And we need as much community participation in these types of studies as possible to speed that process. And a great way to look out for these opportunities and to look out for what's going on in the field is by going to www.hdtrialfinder.org. And HDSA created HD Trial Finder in 2015, and it continues to be the most up-to-date resource for HD clinical trials that are currently recruiting participants. It's a website, it's a free call center that's staffed by clinical trial navigators. You can read about currently recruiting studies in the US and Canada. You can fill out a profile for yourself or a friend or a family member and ask and answer some basic questions to see which nearby studies might be a good fit. There are currently more than 4,600 profiles on HD Trial Finder. We really encourage you to check it out or to try clicking the match button. Again, we're constantly updating the site based on our communications with different academic researchers and industry researchers that are doing clinical studies on HD. And one of the studies that is listed in HD Trial Finder that nearly everyone can participate in is Enroll HD. So we highly encourage everyone to check out this study. It's open to anyone in an HD family, whether that person has HD, is at risk for HD, has tested gene positive, gene negative. It's a worldwide study with lots of sites in the US. It involves one yearly visit to a clinic that will have expert HD doctors, and there will be a few hours of different kinds of movement tests and thinking tests and blood draw, sometimes imaging studies. And the main goals really are to increase how we understand HD, to help improve the design of clinical trials for HD and study the best ways to care for patients and families. And one of the most important things right now that Enroll HD is aiming for is to involve more people who are at risk or who are pre-symptomatic. Because that's really what we need to know more about before it will be possible to run a clinical trial that actually prevents HD symptoms. So HD is usually diagnosed after symptoms develop and have continued to worsen over time for a little while, and really after a person's day-to-day abilities have changed. But there's this pre-symptomatic time where there may be changes in the body and in the brain that are completely unseen from the outside. And so really the ultimate goal of disease-modifying therapies is to lengthen the amount of time that people still have all of their day-to-day abilities and all of their personality traits. And but as I'd mentioned earlier, it's really very hard to test whether a drug is working if a person doesn't have symptoms yet to treat. And that's why today's clinical trials of new genetic therapies are beginning with people who already have symptoms to see if those drugs can slow down the symptoms or stop them from getting worse. But of course, what we really want is a drug that's going to prevent symptoms forever. But we can't do clinical trials that last an entire lifetime. We can't do clinical trials that last a decade because we'd never have a drug approval. So the more that we know about what's changing inside of the body and the brain before symptoms occur, the sooner we'll have new ways to measure whether a drug prevents those changes. And this, in turn, is really going to strengthen the idea that treating HD is not just about calming down a person's movements, that we can and we should measure other types of things in clinical trials and base approvals upon that. And so that's really what Enroll HD and other observational trials are about. It's using those samples and those early exams and thinking tests and brain scans to find the things that we should be measuring. And this is the current breakdown of participants in Enroll, and the investigators are really trying to increase the percentage of people in the study who are at risk or who don't know their gene status or who don't yet have symptoms. So again, we highly encourage checking out Enroll HD. There are other local and worldwide observational studies like Enroll with similar goals to better understand and better measure changes in HD, and a lot of these are ongoing. Some of them are coming soon. HD Trial Finder, again, is a great way to check what's happening near you. So here are some examples. There's a CSF study that involves donating a small sample of the fluid surrounding the spine. There's a newly expanded study on young adults with juvenile HD and at-risk youth. That's webinar that's coming up in February, and when Pagnopoulos is going to speak about that Change HD study. There are local studies that do brain scans or cognitive tests. There is soon to be a study on sperm. There is also HD Legacy, which is a brain and organ donation initiative. And so HDSA is collaborating with the HD Research Foundation, CHDI, to really spread the word about these studies. And we encourage you once again to take a look at HD Trial Finder to learn more. And now I'm going to pass the baton back to George.
All right. Thanks, Leora. So I think I can maybe hopefully speak for everyone where we can say that, we've never been more optimistic and hopeful that these current approaches that are in the clinic will come to fruition and lead to disease-modifying therapies. This, the idea that HD is a monogenetic disease caused by a single mutation in the Huntingtin gene, and if we target that gene, we could potentially modify the course of the disease. Makes total sense. But, it's possible it might not work. And it's really important that HDSA and the higher research community not put all our eggs in one basket, and we continue to invest in novel approaches. We cannot get complacent that the Huntingtin-lowering therapy alone will get us to the finish line. And so, kind of touch on our final point of investing in novel approaches. Can use a kind of real life example that many HD families can kind of relate to, and that is this question that I hear a lot. Why is it that my loved one, I have 40 CAGs and I developed symptoms at 60 or 70, but my child has 40 CAGs and they develop symptoms at 40, 30 or 40 years different in terms of onset with the same exact mutation. That's kind of represented here in this graph up on the right, where you see the people with the same the same CAG repeat length of 40, but very different age of onset. And what we found a couple years ago through the use of the power of numbers, through things like Enroll and Predict, and families generously donating their blood and DNA, was the research has been able to identify a number of new potential therapeutic targets, these genetic modifiers, genes that when expressed in HD gene-positive individuals, seem to modify the onset of the disease, either accelerate it or to delay it. And what was really exciting about these findings was that all of these genetic modifying proteins that were identified to modify the course of Huntington's disease all fall into this biology of DNA repair, how the body handles damage to their DNA. This system that's always constantly monitoring this, your DNA and trying to fix it. And evidence suggests that if we could intervene in this repair pathway, we could potentially alter the course of the disease. And to kind of give you an example of why this is so important, here's one to show that, when you go for a test, so you get this individual here, goes in for a blood test and at age 18, and they're found to have a CAG repeat of 42. If you were to look at their, at their brain or in their liver at that age, you might find that they have a CAG repeat of 42. But then if you, 20, 30, 40 years later, you do the same blood test, what you'll find is that the blood test will remain the same. They'll still have a CAG repeat of 42. But if you were able to take a piece of brain or liver, you would find that they may have 50, 60, or maybe even 100 CAG repeats. That CAG repeat in the Huntingtin gene is very, very unstable for some reason. And you can see it here on the right. This is a CAG, this is a DNA measuring the CAG repeats of an individual that had 41 CAGs and one copy, the expanded copy of their gene, and 16 CAGs. And what you can see in the striatum, which is the region of the brain most affected by the Huntingtin mutation, you have CAG repeats up towards the range of 500 to 1,000 in the striatum of this HD brain. Whereas in regions of the brain that are relatively spared, like the hypothalamus, you see very little expansion. So the idea here, the hypothesis, is that it may not be that it's this 41 CAGs alone, it's that this 41 CAGs expand within the brain, causing damage. So if you could slow down or stop this instability or this expansion of the CAG repeat, you could potentially impact the course of the disease. And a number of companies are excitingly working on this to develop drugs that could potentially interfere with repeat instability of CAGs. So kind of watch this space. HDSA is so excited about it that and think that this area of biology is so important that just in the past couple of years, we've invested around $1 million on research related to DNA repair biology in Huntington's disease. And I won't go through the names of these researchers, you can see them here, but they're all kind of trying to tackle specific questions related to whether it's validating a new target that might be important in CAG expansion or contraction, or just understanding how the DNA repair proteins work in the presence of the expanded Huntingtin protein. So with that, I think hopefully Leora and I have given you a better understanding of what's gone on in the field in the past year and how HDSA looks at this of being proactive in our approach to visualize a new horizon for HD research. And I just want to close by thanking our scientific advisory board. You can see them all here. This is really a world-class advisory board, and we really owe them a lot to help us. They work with us, Leora and myself, to help shape our mission and our strategic initiatives. They're so famous, in fact, that our chairperson, Dr. Leslie Thompson, shown here on the back of a bus driving around all of Southern California. That's how famous our SAB is. So we're really, really indebted to them. And I want to thank you for joining us today. Hopefully this is just the beginning of your year-long education and partnership with us. Continue to participate through webinars, Leora's weekly blog, go to HD Buzz to learn more on exciting breakthroughs that are happening, press releases. Participate and enroll HD. Check out HD Trial Finder to find out studies that are near you, and we certainly encourage you, if there is a center of excellence in your neighborhood, consider checking them out and seeing what they have to offer. So with that, I'm going to close it, and we'll see if we have any time for questions. We have a few minutes. Feel free to ask your questions. Chat. Okay. Let's see if we can get, a lot of the questions are telling us that we don't know how to use PowerPoint, which we appreciate. Give us a minute. It's a question related to HD COPE, providing feedback for young adults who are at risk. How do they do that? Well, it's a good question. The HD COPE is this coalition of global patients and or family members or caregivers, which is represented by youth at risk, gene positive, asymptomatic, as well as caregivers. So we try to have a representation of the entire HD community. So we are make sure that everyone's voice is heard. The question related is patient engagement person focused on clinical trial patients only. I find that so no, I mean, so this question is related to what the role of the patient engagement professional, Sarah, will be at HDSA, and that's still evolving, but one of her primary roles will be to kind of oversee HD COPE and ensure that the sponsors, like the Roches and Waves of the world, or others that are embarking in HD research are getting access to patient and family perspectives. But we're certainly working with anyone even before they get into the clinic to ensure that what they're developing is their trials or their protocols are based in the reality of what patients want.
So we are getting also some questions about access to treatment, right to try, compassionate use, and in terms of getting into some of these ongoing studies. So many of these studies are closed right now, and there was a huge amount of interest in participation. We always encourage people to develop relationships with their HD doctors and with HD medical professionals that have a research interest, like at Centers of Excellence. But we understand that there's a lot more interest than spots in some of these trials. Right now, there aren't any companies that are offering or making use of the compassionate use or right to try laws, but it's definitely something that we are thinking hard about at HDSA. I don't know if you want to add to that, George.
No, you got it. You covered it.
Yeah, it's definitely.
And I can add, there's a question here. No, you covered it great. I can address the question. I apologize for not mentioning this when it related to the reversibility of I had something in there about PTC and Novartis, their oral drugs being reversible. What I meant by that, as opposed to uniQure, the gene therapy approach, when that drug is administered, that drug is there and turned on forever. There's no shutting it off. It's not reversible. We can't stop the Huntingtin-lowering once that virus is injected into the brain. And what I meant with the case of an oral drug is it's reversible in the fact that if you stop giving the drug orally, the body will eliminate the drug, and what should happen is you should be able, if you by accident, administer too much drug and Huntingtin was lowered too much, there's a protection mechanism there. You could stop giving the drug and the lowering should stop.
There is another question related to Huntingtin lowering, asking whether there is any evidence that lowering mutant Huntingtin actually does delay or reverse HD progression. And all of the evidence that we have for that right now is in mice. And it's been quite promising in mice that indeed many of these drugs tend to delay or even to reverse some of the symptoms. But that, again, is in mice, and mice are not people, and that's why these safety and efficacy studies are going on right now in humans. And this phase 3 trial of the Roche drug, for example, is really the first time that efficacy is a major outcome of the trial. So that's the question that's being asked right now, and it's a great one. But there's definitely a lot of evidence in animals that it can be helpful with HD-like symptoms.
There's another question, just kind of clarify about the timing of the Roche treatment and when that may be approved and available. And that's really a tricky one and hard to answer. Because I don't want to get anyone's hopes up, but it's likely several years before that study is even completed and results are available, and then that could take some time before the regulators review it and hopefully approve it or not, which is really tricky. But it won't be a 2020 thing. That's safe to say. Several years down the road before a Huntingtin-lowering drug would be available.
Somebody asked about Enroll HD, and yes, www.enroll-hd.org is the website, and there's lots to explore on that website. There are newsletters, there are interviews, there's lots more information about what it's like to participate and where you can participate. And someone asked who has access to the Enroll HD data for research, and that's a really good question. Enroll HD and CHDI, who is running the study, makes that data available to really any researcher who has a legitimate question to ask about Huntington's disease, whether it's exploring biomarkers in the blood and fluids donated by participants, or using data from cognitive tests and neurological exams to ask questions about early HD. Researchers can apply to use that data in different ways.
Yeah, another And another question related to trial finder. This is a good question, and I apologize if we didn't make it clear. When you do sign up for, set up a profile on HT Trial Finder, the question is it up to us to continue to check in, or will staff at a clinic ask us to participate in clinical trials for which we're eligible without us having to follow up? And really, the Trial Finder is a resource to empower you with knowledge about what's recruiting in your area. And it's really up to you to use that information to bang on doors and say, hey, listen, according to Trial Finder, I or my loved one or potential matches or candidates for this study, can you tell me more?
Someone asked if a copy of these slides will be available. Yes, we are recording this webinar, and within hopefully the next few days, we will be able to post it on our website and on HDSA's YouTube channel.
Another question is, does participating in Enroll HD increase the chances of being accepted into other trials? And that's a great question. And well, there's no list or, for clinical trials for folks to get into these Huntingtin-lowering studies. When sponsors are setting out to figure out where they're going to have clinical sites, they certainly look at the Enroll HD database and to figure out where are the patients that meet our particular criteria. So in the case of the Roche or uniQure studies that are looking for patients in early stages between, say, 25 and 65, that's really a quick search that can determine what sites have patients that meet those criteria. And the more folks you have in Enroll that meet those criteria, the more is the likelihood that a sponsor would set up a clinical site at that institution. If you have just one or two that meet those criteria of 25 to 65 and early manifest HD, it doesn't really make a lot of sense for a company to go through the effort to set up a clinical site for just one or two patients. So I would say certainly enrolling in HD certainly will help increase the chance of maybe not being accepted into trials, but certainly increase the likelihood of your local clinic being involved in these important studies. Another question related to people who participate in Enroll HD have access to the data to better understand what the data is being used for. My understanding, go to Leora's point, the Enroll database is made available from CHDI, and people can submit proposals to them to get access to that database. I don't think that the database alone would be very useful to the typical family member.
Right. When researchers publish their work, they have to cite that they are using data, I believe, from the Enroll HD trial. So as more and more data becomes available, long-term data, more academic researchers are likely to be publishing on that, and that might be even searchable.
Yeah, and upon giving informed consent to participate in Enroll, you're going to be told about the data that you're going to be participating in generating are going to be used to help better understand HD. That's one of the main objectives of Enroll HD. So yes, certainly everyone who signs up should hopefully have an understanding that that's what these data are in many ways being used for, to help identify whether it's new biological mechanisms or just understand HD over the course of individuals' lives.
I think it's getting to be about time to wrap up. Thank you very much to all of you for attending today. Thank you for your patience as we had some technical difficulties there. But mostly thanks for continuing to tune in and stay informed and knowledgeable about what's going on in the HD research field, because that's participation too, and staying informed and And being able to share that info is really is part of how research moves forward. So we're looking to the future, and we hope you are too. Thank you very much.
Yeah, thank you. And don't forget to join us on February 19th for our next installment of the HDSA Research Webinar Series. Thank you, everyone. Have a great day. Talk to you soon.